Let's take a look at subset, proper subset, and empty set. So I have three sets right here. A is from 0 to 8. Set B is 1, 2, 3, 4. And set C is 1, 2, 3, 4, but the element is listed in different order. Okay, so the first symbol that I would like to go over is proper subset. So the proper subset, the symbol looks like a C. So using these three sets, I can say set B is a proper subset of A. So B is a proper subset of A because every element in B is in A. Some element in A is not in B. So 1, 2, 3, 4 is in B, but in A we have some other numbers that is not in B. So we say B is a subset of A, but to be specific, we should say B is a proper subset of A. So what about subset? So if you take a look at B and C, do we agree that B and C, they are exactly the same? So we say C is a subset of B and B is a subset of C. So what is the difference between subset and proper subset? If you just compare the symbol, the only difference, this symbol just like an inequality symbol, right? So one with an equal, one without an equal. The proper subset has no equal, the subset has an equal. Take a look at B and C. Do we agree that they are completely the same? So we say that B is not only inside C, but B is also equal to C. C is not only inside B, C is also equal to B because they are completely the same, right? So the order of listing the element is not important. So basically set B and set B, they are exactly the same. So B is not only inside C, so that means B is a subset of C, but B and C are completely the same. So it's not only inside, but also the same. On the other hand, C is not only inside B, C is also equal to B. So since they are completely the same, so that's why there is an equal. Okay, and then what about B is in A, but there is no equal? Think about this. How many numbers do you see in set A? The answer is there are 9 numbers from 0 to 8. How many numbers do you see in set B? 4. So the size of A is 9. The size of B is 4. If you think about a set as a 2 box, that means A is a bigger box, B is a smaller box, right? So B is inside A, but do you see that there is a picture? Box B is inside box A. Other than that, there are some space outside of box B because there are some element in A. So for example, the 0, the 5, the 6, the 7, the 8, they are in set A, but they are not in B. So that means B and A, they are not completely equal. So that's why we say B is a subset of A, but without the equal sign. So to distinguish the difference with the equal sign, we say subset. Without the equal sign, we say proper subset. And then there is a set D in green. So set D in green is an empty set. So for empty set, we draw a 0 with a slash. Right? So there are several things to remember. Number one, empty set, the 0 and a slash is a subset of every set. So we can say D is a subset of A, D is a subset of B, D is a subset of C. And then number two, every set is a subset of itself. So A is inside itself, B is inside itself, C is inside itself. And then number three, B is in C, right? So B is in C, we use the equal because they are completely the same. It's not only in C, but also equal to C. C is in B, or also C is the same as B. So another way to say this is C is equals to B. All right, so let's take a look at a few problems. Determine whether a set is a subset or proper subset of another set. So in the first example, I can see that in set B, the smaller set, we have 2, 3, 4, 5. And then in set A, we also have 2, 3, 4, 5. But B is inside A, but we have some elements in A that is not in B. So we can only say that B is a proper subset of A. So we draw a symbol like this, looks like C, but we don't say that as C. We say B is a proper subset of A. And then in number 2, set C and set D, they are completely the same. I just listed the order backward, right, in C. 10, 12, 14, 16 versus 16, 14, 12, and 10. I just list the numbers backward. So this one I can say D is a subset of C, right? Also, they are the same. And the other way around, so C is a subset of D, and they are completely the same. And then in number 3, set E is empty set, so that means there is no element in set E. And then set F, we have 3 letters X, Y, and Z. So here is what we can say. We can say that E is inside F, because every empty set, still remember every empty set is a subset of every set. So E is a subset of F. That's it. Alright, moving on to the last problem in this video. List all possible subsets for the sets below. So in set A, we have 2, 4, 6. So here is how we list the subset. The first subset is the empty set, 0 and a slash. And then following the empty set, we have to consider one element only, which is 2 only, 4 only, and 6 only. And then we consider 2 elements. So we can grab 2, 4, and then we can grab 2, 6, and then we can grab 4, 6. And then you might ask me, hey, can I switch the 4 and 6 to make another set? The answer is no, you cannot. The order of the element is not important. So that means you cannot switch 2, 4, 2, 6, 4, 6 to generate another 3 sets. All right. So we already consider nothing, 1 element, 2 element, and the last one, of course, 3 elements, which is 2, 4, 6. Again, do not reverse the order of the elements to make new sets. All right. B, W, X, Y, and Z. So first, let's consider empty set. And then we consider 1 element only, W, X, Y, and Z. Okay, 1 element only is done, and then 2 elements only, WX, and then WY, and then WZ. Anything else? XY, XZ. Anything else? Yep, YZ. That's it. Do not switch Y and Z to generate another set. So the 2 elements only is done, and then 3 elements, so WXY, and then WXZ, and then what else? WYZ. And then the last one is XYZ. And then the 3 elements only is done. The last one is 4 elements, so which is W, X, Y, and Z. As you can see, every list I list out is an element. Sorry, it's not an element. It's a subset of the given set B. Okay, so this is the end of this video. If you think my instruction is helpful, let me know in the comment below. Like the video, share the video for me, subscribe to my channel. Appreciate your help and support. See you all in the next one. Signing off for now.